When we looked at the esterification of carboxylic acids and alcohols to form esters, I pointed out that it was a reversible reaction. So in section 17.4, we're going to look at the reversible reaction of esterification and the reverse of the formation of an amide. And this process, whether we're talking about breaking down of an ester or an amide, is known as hydrolysis. So the word hydrolysis, this lysis comes from the Greek to break apart. So hydrolysis means that water is going to react with another molecule and it's going to break apart. And that larger molecule will take parts of the water molecule to form two smaller molecules. And in the hydrolysis of esters, what's going to form is the original carboxylic acid and original alcohol. So it's helpful to remember which part of the ester came from the carboxylic acid. And it is the carbonyl carbon and the R group directly bonded to that carbonyl carbon. So when an ester is hydrolyzed, the part that came from the carboxylic acid is going to go back to a carboxylic acid, so it needs a hydroxyl group from the water. So the OH from the water will take the place of the ether linkage that came from the alcohol, and we'll get our carboxylic acid back. And the hydrogen from water will attach itself to the alcohol part of the ester to get back our original alcohol. And it's similar with hydrolysis of amides. So on this slide we see a tertiary amide is reacting with water. Hydrogen from a water molecule is going to go to the nitrogen part of the amide to form the original amine. And then the carboxylic acid part of the amide will react with a hydroxyl to form the original carboxylic acid. So as we figure out what the products of hydrolysis are going to be for the amide and for the ester, we want to remember that the carboxylic acid will go back to the carboxylic acid. We just have to identify what part of the molecule is the carboxylic acid, and that will get the OH of the water. And then the amide will get a hydrogen, or in the ester, the ether linkage will get a hydrogen to go back to the alcohol.